Hey, so I'm Danny Trapphagen, and I'm a senior solutions architect in the startup space. I focus on healthcare and life sciences customers, but I have a long history in helping startups. Actually, my last company is here, and they IPO'd not too long ago, and that's Confluence. But I've been at a series of startups serially, and so I have experience, all kinds of experience with startups. I know what it's like, I understand, and I have a lot of empathy for the journey. So today, actually, what we're going to be discussing is Sofar Ocean's journey and what they're building in terms of ocean intelligence, their application, and their ocean. Their largest network of ocean sensor devices as well. So Ariel Rhoda is accompanying me, and she is the head of product at Sofar Ocean. So she'll be talking about their mission, their architecture, and their core goals for sustainability as well. All right, so with that, let's get started. Okay, in terms of the agenda, what we'll do is we'll first discuss why startups would want to even use AWS. You know, what is it about AWS's solutions and the challenges that startups face that make it a really good match? And then from there, we're going to talk about what startups in the sustainability space are building on AWS. This is a space that you might not be totally familiar with. If you are, awesome. We're happy to take questions at the end, or you can come up to myself or Ariel if you have further questions for us. And then after that, we'll address Sofar Ocean's mission. Ariel will kind of discuss what they're aiming to do. She'll talk about their, like I said before, the largest ocean sensor network, their system architecture on AWS specifically, and then we'll also talk about their carbon mitigation strategy. Okay, so maritime shipping has probably been brought into your consciousness recently because you haven't gotten a package or two, yes or no? Yep. And does anybody remember this crisis or know what boat this is and what canal this is? If you do, call it out. You get it right? All right, gold star. Yes, so this is the Ever Given, and not too long ago, it blocked a lot of goods in the Suez Canal. And so there are increasing issues that we have and as a post-pandemic reality, and also with increasing concerns as far as climate change. And so Ariel is actually going to talk us through what some of the solutions Sofar Ocean is providing for sustainable routing and shipping. And it's pretty interesting, so stay tuned for that. All right. And so you've probably felt the impact of this and can understand why this would be a really good problem to target. And then we'll talk a little bit about what could have gone differently with that as well. So first of all, why startups on AWS? So I think one of the most important bits is that startups need to be agile. They need to move really, really quickly. And we love startups because they transform entire industries and they reshape how we consume by delivering products and services that are very different from the world before, right? So in the photo to the left on the screen here, you see the Model T assembly line. And this is back in the 1920s, so 100 years ago. And this concept totally reshaped manufacturing. And what it did was made it a lot more efficient. And so this led the transportation industry into a golden era. But now fast forward 100 years, and the transportation industry looks a lot different. There are new challenges as all of the biggest companies shift to an all-electric future. So Rivian is probably a startup you've heard of before. Yes? Nod, nod. Okay, cool. They're a well-known EV manufacturer if you don't. And they're taking advantage of HPC or high-performance computing workloads on AWS. They reimagined their entire path with actually assembling vehicles using a computer-aided engineering pipeline. They first test the viability of their designs as simulations, and this has become a really commonplace practice now in EV manufacturing. Let's test the viability because now cars are even more data-driven, right? It's all real-time data that's streaming, metric health checks, heartbeats, things like that. And so to test that before it ever reaches the production line, it really comes to a cost benefit for startups. So that's why they invest so many resources in it. A challenge that Rivian had was back in 2020 with their HPC workloads, which were predominantly on premises at the time. And what occurred for them was they just hit really bad resource bottlenecks, and this was going to delay their product delivery timelines. So what they did is they evaluated how long it would take to scale those HPC clusters, around 2,000 cores in each of them, and they realized, this is going to be 6 months to launch this. And so that wasn't a really tasty option for them. And they decided to turn to AWS. They were able to actually do a POC in 3 weeks with AWS and test the validity of the solution, which allowed them to move a lot more quickly, which was important for meeting their product delivery dates. So this kind of underscores why startups would need the agility of AWS services to spin up resources on demand. Because 6 months to wait for on-premises resources is a pretty long time in startup land. So all of that I just walked through is actually available if you want to take a snap of the link on the screen. And if that's a relevant space to you, on the Scale Out Computing Infrastructure Guide. This is a reference implementation that you can take a look at later. Looks a little something like this. And within it, you'll see how they schedule and launch EC2 instances, and then how they leverage Amazon FSx for Lustre, which is a wonderful service. A lot of my customers use it in the life sciences space for genomics workloads, but highly performant. And so they use that amongst other AWS services as well. Cool? All right. So let's talk a little bit more and build into that kind of concept around why startups would even look to AWS. So, they also need the right tools for the right job to even move quickly. AWS has over 200 services and counting. By the time reInvent is over, I'm guessing it's going to be another number I have to memorize. And since I started at AWS just a year ago, we've already launched dozens of new services. So the pace of innovation here is truly jaw-dropping, and that's because our customers set our course. Customers really define what we built here, with 90% of the roadmap being customer-led. And so the range of technology options as an outcome of that, because of the diversity of our customer base, really runs the gamut. So, obviously you can turn to services in AI, ML, IoT, data lakes, and analytics. Actually, yesterday, I had a member of the audience ask me, well, startups need to move fast, but AWS has 200 plus services. So those two things are kind of counterintuitive. Like, how do I navigate and know which of these services to use? How do I know how to architect it? And the answer to that is multi-pronged, right? So you want to approach things with not only a training mindset, so going in and learning as much as you personally can, but also turning to AWS for support. We have amazing startup programs, which you're welcome to ask me about later, including credits and support for you as you build out these architectures, and make sure that your solutions are robust. So that's just a little nutshell on how you can help, how AWS can help you through your startup journey. Okay, and so next, startups need to run lean, right? One of the things that I realized in all of my past lives at startups is that it's easy to kind of get a product out the door. But once you do, you have to scale it, and you have to work seamlessly through other lines of business within your startup as you start to grow those organizations. And that's where I found the most bottlenecks to exist, is playing nice with your neighbors within a company. And so, if you look at most companies' on-premises infrastructure management, like we saw in the case of Rivian, it can take 6 months to get that up and running. Well, if you're a completely different team with different interests and pursuits, that's going to slow you down majorly, and that's going to cause a point of friction between you and the other team, right? So one of the ways that AWS can help is to get you, to fail fast, because you actually have the tooling that you need to launch that and understand what works and what doesn't, right? And so I'd say there's really four main aspects of building a lean startup. And the first is just little to no setup costs, right? You can kind of start with your product design with pay as you go, and you don't have to estimate how many computing resources or do that crazy napkin math to figure out exactly how much you need to spend on what. This is something that we dealt with actually at one of my former startups a lot. How do we even charge for this? What should our pricing model look like? We don't even know how much we're going to use. How would we know what service to use if we don't know what we're going to use? But what's nice about this is you can kind of get things up and running and just pay as you go. The next thing is launching faster. So the on-demand infrastructure allows startups to really spin up computing resources in a matter of minutes versus weeks or months, like we saw with Rivian. And that helps a lot in the startup journey. Also, kind of experimenting often at lower risk. So you can test the viability of your designs far before it becoming a mission critical aspect for the business. And so you build iteratively, you fail fast, and then you correct from it. And so yeah, you might hit some failure, but ultimately you can course correct from that and refine your product offering to something that will succeed. So we'd prefer to encourage the fail fast process rather than putting a lot of upfront resources, contracts, expensive investments into something that's ultimately just going to flop, right? And then the last thing is focusing on your core business value. So we want to support you being able to build a viable product at the end of the day. That's what you should be doing. You should be focusing on your services and your tooling and your product and not the underlying infrastructure. That's not really something that a startup can take on easily and still focus on creating a beautiful product for their customers. Okay, so now that we've kind of discussed that, that's sort of the foundation for why startups would use AWS. Let's talk a little bit about some customer example use cases in the sustainability space. So there's already a multitude of startups, their names, which you can see on the screen, in the sustainability space that are building on AWS or using services and tooling across a wide array of industries. And so some of them you might have heard of, others are probably completely new to you. We already talked through Rivian and what they're doing with one of their use cases on AWS. So let's talk through some others. All right, fun fact. Did you know that 75% of our global crop distributions depend upon our pollinators? It's a pretty high percentage, actually. And so pollinators are really essential to our food production. And with threats like pesticides and habitat loss, they're certainly a good focus for conservation efforts. Beewise is a startup that's focused on this specifically. Their interconnected network of distributed beehive devices allows them to collect large amounts of data in real time and then evaluate those in aggregate. And their product heavily relies on AWS services like AWS IoT Core and AWS IoT Device Management. And so they basically provide a centralized repository of the bee health for their customers. And as an outcome of this, in their product, they were able to increase plant and honey production while decreasing bee mortality rates from 40% down to 10% in their robotic beehives. Next up, this is a really cool example in the sustainable agriculture space, and it's the great work that's being done by CropX. So they are a soil sensor and analytics company, and they're improving crop yields while reducing water usage, which is really important in certain states that are our neighbors. And so CropX is helping farmers to address these challenges by using more accurate in-soil data sensors rather than just manually collected, error-prone, above-ground data sets. And one of the challenges that they actually faced early on in their mission was that they were limited by a factor of scalability for the in-soil data sensors they were using. So to solve this problem, they decided to run their solution on AWS. And so they captured data from thousands of these globally deployed soil sensors. And they combine that with the above ground sets as well. So to give you an idea of kind of what that looks like, the data is pretty much integrated with a number of things. It's imaging data, weather, topography, and soil data, and it's analyzed by an algo to provide analytical insights via the CropX web or mobile app. So by running on AWS, CropX is able to help its farming customers contribute to increased sustainability, using less energy and fewer resources. And for farmers specifically, they can just use a digital app to understand, how to optimize their irrigation systems, how to spend fewer resources on travel and equipment, which for farmers, if you know or you know any farmers or farmed before, you know that that's a really costly thing to face. So farmers can use their soil data insights from CropX and maximize their yield potential and better control for irrigation as well. This helps to kind of solve the solution around over or under irrigation, which has more global effects in terms of water usage and being efficient that way. All right, and so for our customer highlight, we'll talk about Beta Technologies. And so what Beta does is they develop an electric vertical aircraft, which is pretty exciting. So something you might not know is that aviation today represents 12% of global transportation-related CO2 emissions. And so with cars, trucks, buses, trains, and boats all having transitioned to electric motors, that percentage within aviation is going to grow significantly unless we take action. So Beta Technologies has turned to leveraging rapid advances in battery performance to make sustainable electric flight a reality. And their electric vertical aircraft, you actually see right here on the left-hand side of the screen, is called ALIA. Now, ALIA was originally designed to actually transport organs for patients based upon its horizontal and vertical flight capability. And now they're seeing, oh, wait, we have other possibilities here. And so they have just announced for customers in the cargo, government, and passenger use cases as well. This is a really tremendous leap forward for aviation, and it creates a 3D solution to growing 2D problems like traffic and geographic constraints as well. So it's not really too hard to envision a future where there's a green delivery option, and your package is available to you no matter where in the world you are. Right, so that's kind of a place where Beta is looking to go next, and they're creating infrastructure that's going to enable their aircraft to do so. So they're building a network of charging stations throughout the United States and deploying immersive simulators that's going to train the next generation of aircraft pilots as well. And so to test, develop, and scale this type of business, especially when you're dealing with regulations and creating a completely new form of transportation, it requires really rapid feedback loops and agile systems. And so they use AWS for that. So here's a little bit on how Beta Technologies is using AWS. You can already kind of see like the flow, produce, consume. This is a lot of real-time data, right? So through its flight test program, Beta gathers hundreds of gigs of data from the aircraft, and it uses that to analyze individual component performance, both in air and on the ground as well. And so in certifying a new type of revolutionary aircraft design and propulsion system, they have to prove to the FAA that their aircraft is safe in all modes of transport, as well as in any condition that it might encounter in the air. Analyzing this data in real time and using kind of high fidelity simulations allows Beta to demonstrate its safety profile to regulators and accelerates their time to market. AWS plays a really critical role in providing foundational IT and software infrastructure, and how I was talking about efficiently working cross-functionally between your teams earlier as a startup being a really important thing. That's kind of how they focus on creating actionable design considerations cross-organizationally. They use Control Tower, EC2 instances, Transit Gateway, Backup DR, amongst other services. And they push large amounts of data to teams of engineers at Beta, waiting to ingest and analyze that in a host of different applications, just to understand what's our performance in this design. If we've pivoted or changed something, how does that impact our safety profile, risk assessment, those types of things. So the resulting analysis drives agile decision-making processes across the organization, and it impacts every single employee at Beta. So they're very focused on being data-driven in all of the decisions that they make in their design. So Beta has actually more than doubled their headcount this year, and they continue to plan to scale. Okay, so with that introduction into what a number of different startups in the sustainability space are doing on AWS, I hope you enjoyed it. We'll now turn to Ariel to talk about Sofar Ocean's journey specifically. So why don't you come on up?
Awesome. Thanks so much, Danny, for that introduction. This is Sofar Ocean's first AWS conference. We're really excited to be here. As Danny mentioned, I am Ariel. I'm head of product here at Sofar. And at our core, we really are an ocean data company. We believe that making ocean intelligence accessible to science, society, and industry will power a more sustainable future. So today, I'm going to start a little bit with Sofar's mission, an overview of our company, our products. We'll do a little demo, and then I'll talk a little bit about how we've been building with AWS and how AWS has supported us through our most both from the early days and up until our most recent scale. We recently raised a Series B. We're super excited about it. So, Sofar's mission is to connect the world's oceans to deliver insights to science, society, and industry in service of a more sustainable planet. Our oceans make up about 70% of the planet, but only recently have we begun to understand the massive role they play in regulating the climate, absorbing solar radiation, storing heat, storing carbon dioxide. About 3% of global GDP and industry operates on the ocean's surfaces. About 90% of everything you touch has been transported by sea, and almost all major cities are situated along the coasts. But we have a massive ocean data gap. In many ways, we know more about space than we do about oceans, and we collect shockingly little information about our oceans despite the massive impact they have on society and industry. And so what we here at Sofar set out to do really starts with closing that ocean data gap. Our foundational technology is a sensing system called Spotter. It's about the size of a basketball. It is solar powered. It's a metocean buoy, and it captures real-time data on wind, waves, sea surface temperature, precipitation, and atmospheric pressure. And with recent advances in small-scale technology, much like we saw with the CubeSat revolution, we're able to build it at about 1/10 the cost of existing ocean sensing systems. Over the last 2 years, we have deployed spotters en masse to create the world's largest real-time ocean sensor network. We have thousands of spotters drifting around the world's oceans. We have coverage in every major ocean basin, and we capture about 100,000 unique ocean observations every day, which we also make available to the scientific and academic communities for climate and sustainability research. With this network of real-time spotter observations, we're also able to build the best ocean weather forecasts. So by assimilating those ocean observations into global forecast models, we've been able to improve the accuracy of current best-in-class forecasts by up to 50%. So what you're seeing here with this chart below is actually a chart of the forecast error reduction we've been able to achieve by assimilating spotter data. You can see that typically the higher the energy system, the greater the error reduction we're able to achieve with Sofar forecasts. But what I'm here to talk about today more specifically is the dive we've taken in the maritime shipping vertical to service greater global sustainability in that space. So maritime shipping alone is responsible for about 3% of total global carbon emissions. Of the $200 billion in revenue made by the shipping industry every year, $100 billion of those dollars goes towards non-renewable fuel. But things are beginning to change. The International Maritime Organization, the regulatory body for shipping, has really aggressive carbon reduction targets for 2030. And this past June, they implemented a new wave of CO2 regulations, which require all existing international cargo-carrying ships to begin reporting on carbon intensity. This is basically an emissions efficiency metric. So sustainability and emissions reduction is top of mind for every international shipping group out there these days. And to service that industry, building on the largest ocean sensing network and the best ocean weather forecasts, we recently announced the public launch of Wayfinder. You can think of it like Google Maps for the oceans. We help ships route more safely and efficiently from port A to port B by advising them on how to navigate through changing ocean weather conditions. And by leaning on these highly accurate forecasts, we're able to help these companies take advantage of favorable weather conditions, advantageous waves, winds, and currents to reduce resistance on their vessels and thereby reduce the fuel consumption required to move their vessels through the water. So I can show you a quick little demo of Wayfinder in action. All right, so through the Wayfinder application, captains can gain situational awareness of the weather context that they're going to experience along their route. So we just saw waves. You can see wind and currents that they're able to look at through our platform. They're able to project their location forward in time to see how that weather changes along their path. They're also able to look at spotter observations to validate our forecasts, to see that real-time data. And every day we deliver updated speed guidance or updated waypoint change recommendations based on those changing weather recommendations. So they can look at the routes that we've suggested, evaluate them, and follow them to sail more sustainably and efficiently. We're helping these shipping companies maximize both profitability while minimizing emissions so that they can hit both their business and their sustainability targets. So now that you know a little bit about how our application works, I want to get into our optimization. This is optimization engine. This is really what powers the Wayfinder platform. So the optimization engine itself takes into consideration three major inputs. The first is market factors. So you can think about these as the economics of the voyage and voyage profitability. We require a price of fuel. That's one of the factors we take into consideration, as well as an opportunity cost of time or a required time of arrival for companies that have to maintain certain schedules. With the recent regulatory changes, we're also working with certain customers to put a price to carbon to factor that into the optimization as well. The second main input for us is the vessel performance model. So this is a custom model we build for every vessel that we route. And essentially, it's a way that we that the model itself describes how fast a vessel will travel and how much fuel a vessel will consume. If it travels at a certain number of rotations per minute, that's the propeller speed, and through certain weather conditions. So to deliver route suggestions, we need to be really confident that the vessel will perform how we will expect in terms of speed and in terms of fuel at those conditions that we recommend. And then last but not least, we've got the input, which is Sofar weather. So we produce and deliver high accuracy forecasts every 6 hours and continuously update our routing guidance based on that new information. So now that you have a better sense of how the app and the platform work together, I can talk a little bit about how working with AWS has enabled us to scale over the last couple years. At our core, again, we are an ocean data company, and AWS's infrastructure has been central to enabling some of the most foundational and critical data management operations. There are two kind of main product areas and resource areas that have helped us scale effectively. The first is access to cloud compute power we really wouldn't have been able to obtain any other way. So part of our promise to customers is delivering the best marine weather forecasts available. And to this end, we run a global, high-resolution numerical weather prediction model. These are the types of forecasts that were a major driver in the development of supercomputers of the past. So government agencies like the National Weather Service still build and operate supercomputers to run the publicly available forecasts that you see today. Many of our legacy competitors in the weather space that were founded decades ago spent millions building out their own infrastructure, and supercomputers, dedicated hardware, data centers, specialized operators. And for us to go the supercomputer route would have been far too capital intensive. Instead, we were able to work with AWS, click to provision enough computer optimized EC2 instances, install our code, and just start predicting the weather. Another advantage for us is that because we're able to run containers on our Kubernetes pods, our ocean science team is able to iterate on model logic, develop new approaches to forecasting without having to worry about infrastructure concerns. For us, really, the ease and the speed with which we've been able to do more with AWS has really been critical for us as we scaled. The second major kind of categorical use case for us working with AWS has been a suite of services that we simply need to plug into, sort of convenient services for us where we didn't need to build things ourselves. So the big example here for us are AWS, simple email service, and Lambda. The shipping industry is still very much in early days of digital transformation. Much of the data exchange that's done between oceans and shoreside, between captains on their vessels and the shoreside operators, is done through email. As I mentioned earlier, having a high accuracy vessel performance model is really critical to our optimization, and we need a continuously up-to-date picture of how a voyage is progressing to ensure that our model is performing as we expected. Is that vessel traveling at the speed that we thought it was? Is it consuming the fuel that we expected to? Is it on track, or has it deviated course? And so in the shipping industry, all of this data is available in the form of a noon report. So this is a report that's shared by a captain, delivered to an operator via email, which details the last 24 hours of sailing. So it's got a snapshot of fuel consumption, RPMs, speed, other relevant vessel and engine conditions, all of which we need to monitor and tune our vessel performance model. Every shipping company does this a little bit differently, but they all operate through email. So for us, leaning on AWS SES to forward the email messages to S3, and leaning on Lambda to process the data contained in those messages, we've been able to continuously finesse our models and also quickly onboard new customers. So this has been super useful to us as we've grown our fleets and grown our customer base in recent months. These services just already existed for us. We were able to plug in and get up and running with them in a matter of weeks, which was really awesome. So we have a number of customers across the container space, dry bulk, tankers. I want to give you a little example of Wayfinder in action. So this is a recent voyage sailed by a major bulk carrier of ours from China onto Singapore, onto Brazil. And the original route they shared, you can see that's the gray dotted line there. And the route that they ended up sailing with the Wayfinder service is that blue route over there. They sailed a 35-day voyage. We delivered to them updated speed guidance every single day of that voyage and 3 recommendations on actual course changes based on the weather that we saw. And what you can see here is the difference in weather conditions they were able to experience as a consequence of our route recommendations. And you can kind of better understand here how better weather data contributes to improved efficiency. So this chart here on the left shows you on the x-axis, you can see a number of wave heights, so in meters, 2 meters, 2 to 3, and all the way up to 4+ meter waves. And on the y-axis, you can see the number of hours that the vessel spent sailing through those conditions. So the actual route that they sailed with us, you can see we got them entirely out of all 4+ meter waves. This is great not only because it means there's less resistance on the vessel, but anything greater than 4+ meters is actually a pretty big safety concern for a lot of captains. So we were able to route them completely out of the 4+ meter waves, saved them 20 hours of sailing in those unsafe conditions. And you can see also on the far left, we were able to get them almost 25 hours extra sailing in sub 2 meter waves, which are really the calmest conditions that they'll be able to sail at sea. In this graph on the right, you can also see that it wasn't only waves we were able to help this vessel navigate through, but we were able to help them take advantage of favorable currents along their paths. So the intended route that they had planned to sail, they got a modest benefit from the currents at hand. They would have been able to sail at an extra 0.12 knots faster. But with the Wayfinder product, we were able to help them direct into even more favorable currents. So the advantage that they saw there got them closer to 0.3 knots faster, which over a 35-day voyage is actually really meaningful. In all, for this particular voyage, we were able to help this vessel save both fuel and time. That is the best case scenario for us. On this voyage, we saved about 139 metric tons of fuel. That's about 8% less than what they would have otherwise consumed on this voyage. And with that was about 433 metric tons of carbon dioxide. So when you compare that to number of cars we could have taken off the road for a year with that number, it's about 100 cars. This is pretty meaningful, especially when you think about the fact that this is one vessel on the ocean of 56,000 vessels, and we're talking about a 35-day voyage out of the entire year. And these results are not only meaningful as they relate to carbon reduction and fuel reduction, but they're also resulted in a more profitable voyage for the customer. So they were able to save $45,000 based on those fuel savings and based on those time savings. And this is something that we're hoping to do for every vessel on the water, particularly those large cargo carrying vessels. So to close, I just want to say we're super grateful to be partnered with AWS over the last couple years as we scaled from our early days all the way up to our Series B. We are hiring. If any of these challenges excite you, would love to chat about that. But we're really looking forward, and we're excited to continue to innovate across hardware, data, and software lines to push sustainability efforts forward into the future. So thanks so much, and I'm happy to take any questions you have about Sofar system. Sure.
So 2 questions. Is there any reason you don't take, say, an AIS feed as well as as the Noon?
Yeah, so we actually do take an AIS feed as well. The Noon reports are important because AIS can get jammed up in certain parts of the world.
Yeah.
So we take both. We would take both.
And have you considered making your weather forecasts available for normal sailors as grids or something like that?
Yeah, that's absolutely that's absolutely something that we're thinking about as well. I think we've got a lot of traction and momentum working with some of these larger shipping groups, but we do want to get our weather into the hands of as many people as possible. And so thinking about how we extend that to recreational, large fishing, that's also on our roadmap as well.
Any other questions?
Great. Can I hand it over to you?
All right, thanks everyone. That was the session. If you have any other questions, please come see us.